Okay, this is going to be exercise 11 from the practice paper. And in this, we're going to look at shapes of molecules. So the first one we get is AlCl3. So an interesting molecule, really generally ionically bonds, but we can force it to covalently bonds. And that aluminium, only 3 electrons in its outer shell, so it doesn't really follow the octet rule. But it still can bond like this, where we have aluminium in the centre, with 3 chlorines singly covalently bonded around it. So if we look at the bonded pairs around the central atom, and when we're doing this, we only look at this central aluminium. Don't worry about the chlorine. That has got 3 bonded pairs. There's 1, 2, 3. It has no lone pairs. So there are no free electrons at all around the aluminium. There are around the chlorines, but we only look at the central atom. The shape of this will be Al, Cl, Cl, Cl. We call this trigonal planar, and the bond angle is 120 degrees. Next one on this, silicon tetrahydride, SiH4. So silicon, just below carbon on the periodic table, 4 electrons in its outer shell. So it's going to form 4 bonds with 4 hydrogens. So 4 single bonds gets it nice and stable. That gives us 4 bonded pairs, no lone pairs around the central atom, and that creates a tetrahedral shape, which looks like this when we draw it out, with this wedge representing the hydrogen coming out towards us, that hydrogen with the dotted line going away. And that's how we draw our 3D structure. Bond angle on this, 109.5 degrees. Final one, hydrogen sulfide, H2S. H2S is a sulfur, which is in group 6. So 6 electrons in its outer shell. So it forms 2 covalent bonds with hydrogen to get it up to a full outer shell. That has got 2 bonded pairs, 2 lone pairs, and that is going to form a non-linear shape. And the bond angle in this non-linear shape is 104.5. You could call it bent. The reason why it drops so much, the lone pairs repel more. So these bonds get pushed closer together. So rather than being like 109.5, we saw in the tetrahedral structure, lone pairs push it closer together. Each lone pair pushes by 2.5. So 2 lone pairs drops it down by 5, from 109.5 to 104.5. And that is exercise 11.